Hey, boys and girls. So, for today's activity, we are going to do a lab based on density. Density is simply defined as an object's mass divided by volume. So, to review some of those terms, mass is really the amount of matter packed inside of an object. And so, you look at all these objects over here we're going to be using numbers 1 through 12. You can ignore the crowns down below. But mass, here on Earth is kind of like a component of weight, kind of like that ish per se. Weight is using mass times gravity, but needless to say, mass is how much stuff is packed inside of an object. So we take this object, this random triangle over here, and put it on the scale. It does make weird noises. You can see how much it weighs, and that's 19.5 grams. Remember, grams are the units for mass. When we get to volume, remember volume is the amount of space an object takes up, and our volume can be measured in cubic centimeters or we can measure it in milliliters. Those are both the same, they're both equal. Cubic centimeters, remember the formula for volume is length times width times height. And so if we had an object that had flat edges, we could use a ruler or a meter stick to actually measure the edges of that, multiply all three, and find out what is the volume of that. That would be in cubic centimeters. If we have an object like any of these other ones that are round or just difficult to measure their edges, we could use a method called water displacement. And so the way we do that is we take the object itself, we drop it in a graduated cylinder like we did before. Notice the volume in here already, it's at 400 milliliters. When we drop this in here, notice the change. It goes from 400 now up to 409.7. That 9.7 difference, that is the volume, how much the volume has changed. And so now we have the volume of the object by simply looking how much the water level changes. That's what's called water displacement. And so finally, looking at density over here, if you look at density, density by definition is mass. It's your amount that it weighs, mass, divided by your volume, how much space it takes up. And that gives us density. One cool thing about density is it can tell us whether or not an object sinks or floats if we drop it in water or any kind of liquid substance itself. So let's take a look really quickly at the document you'll fill out. So down below here, here's some objects, and you're simply going to talk about whether or not you think they'll float in water or sink. Just give it your best guess. Why do you think some objects float, and why do you think they sink? Fill that out. Those are the prior knowledge questions for the activity. So once again, when we got to find the mass of an object, I told you that mass was the amount of matter inside an object. For number one, you'll take it and put it on the scale over here. And now you can see the mass for object number one was 19.5 grams. So you'll just simply type that in, 19.5 grams. Volume, remember, is the amount of space an object takes up. And so you'll take the very beginning, you're going to take we're looking at the amount of water we begin with in the cylinder, and that's at 400. This is teaching us water displacement, so we'll have 400 milliliters. And now we're going to drop number one into this graduated cylinder. And now we can see it went up to 414.2. So now we're at 414.2 milliliters. So now the volume, what is the volume? What's the difference between those two? The nice thing is the gizmo calculates it for you at 14.2. So now I have my 14.2. That's my actual volume of this object. So now if we want to figure out if it sinks or floats, we could drop it in this beaker of water and see what happens. I'm going to hold off on that and just go back to the lab now. And so what you're going to do in this part, when you get to activity A, is you're going to grab a number of different objects and just start to drop them in the water. Figure out what's going on. Think about what's happening. Do they sink or they float? Why are they sinking? They floating? You're going to start collecting some sort of data, and the data you're going to collect will be down here. So you'll put these objects on the scale, get all the masses of them. That's numbers 1 through 12. Get all of the volumes of them. And then tell me, do they float or do they sink? And that will come from dropping them into the liquid over here of the actual beaker itself. So tell me what they float or they sink. For right now, leave this final column alone just for now and fill this table out with the mass, the volume, and whether or not they float and sink based on your experimentation. Once you get past this part, you're going to start looking for patterns in your data. So, can mass alone tell us whether or not an object will float or sink? Tell me what you think about that. Or volume. Can volume tell us whether or not an object will sink? Look to see if there's any patterns up there. And finally, you're going to compare the mass and volume of each object. What's the true mass and volume of all the floating objects? So the volumes of the ones that floated, what's the true mass and volume of all of them? What's the true mass and volume of all the sinking objects? So what do you notice about them? Let's go down below here. So now we're going to get into calculating density. Density is simply mass divided by volume. So you'll have your table here and you'll take what's here in mass, divide that by volume. Okay, you'll do that. And then once you have that density calculation done for all of your questions, you will then take a look at which objects floated, which objects were sinking. That will give you some clues to what you're observing there. Once you have that down, you'll notice a pattern and you'll describe what you noticed about the mass and the volume. Can you predict whether or not an object will float or sink in water? That's your conclusion that you're going to sort of wrap up part A with. When you get to part B, we're now going to experiment not with the objects themselves, but now with the liquid itself. For the entire activity, the liquid, its density was at 1 gram per milliliter. That's the density of water on Earth. And so we're going to leave it as is. And so you're going to now take an object like number 1, drop it in the beaker. Let's go ahead and drop it over here. And you'll play around with this slider. Move it to the left, move it to the right. What do you notice about when the liquid becomes less dense versus more dense? What happens to the objects? Do they sink or do they float? You can kind of see what's going on here when I make it more dense. More dense is kind of being more thick, kind of like honey or molasses, something like that's really thick. And so what happens to the actual objects when you notice that? So then you'll form a hypothesis, and that is you're going to tell me sort of an if-then statement. So if the liquid is more thick, what will happen? That is, if we make it more dense up here like 2, or if we make it less dense, what would happen to these objects? Would object number 1 float, sink, or would it sink the whole time? So you'll describe what will happen. Will objects float or sink based on changing the liquid density of them? Okay.